All right, so exciting times. We're going to go ahead and start chapter 7. And in chapter 7, we're going to be learning about something called a system of equations. And so a system of equations sounds pretty fancy. And really, it just means that you have more than one. And what you're going to be looking for, like always in math, is a solution. A system of equations is more than one equation, but it's also more than one variable. And so a solution is going to be an XY pair or an XY coordinate pair that makes both equations true. So typically you are solving for X. There's one variable in the whole problem. You work your way through it. You find out what X is. You plug it in. You see if it works. You're good to go. What you're seeing here when it's telling you in this first example, it's saying, is 1, 5 a solution to this system of equations? Well, what that's really asking you is if this is your X and this is your Y, does it make both of these equations true? So I have to check. So I'm going to put in the 5 for the Y in my first equation and the 1 for the X. And so I'm taking this first equation and I'm plugging in the XY coordinate pair that they're asking me about. So then when I look at that, it comes out to be 5 equals 6, which is clearly not true. If I put my same pair of points, 5 goes in for Y, and then 1 goes in here for the X, that would turn into 5 equals 2 plus 3, which is 5, and that one's a yes. But because it has to be true for both equations, so it works in this one, but not in this one, then you have to say no. 1, 5 is not a solution to the system. You don't have to write that all out every time, but we're learning today, so I'm writing it out for you. It is a solution to the second equation. It worked in there just fine, but it didn't work in the first one. And it only takes one no to say, hey, this can't be the solution for the system because it has to work for everything, and it doesn't. So that is a no. Now, some of your questions are going to be just yes, no answers. But for the sake of showing me what you're doing, I'm going to be asking that you show the work, which is nothing more than kind of these processes that I showed, putting the numbers in and finding out in the end, does it come out to be a true or a false statement? And then you can decide yes or no based on that. So again, it's asking, is 410 a solution of the system? Well, I need to plug it in, keeping in mind that these go alphabetically. So X is going to be a 4 and Y is going to be a 10. So in the top equation, 10 equals 4 plus 6. That turns into 10 equals 10. So that is a yes. So I'm halfway there. Now, if it had come out to be a no, I technically could quit at that point because I only need one no to say, hey, this is not a solution to the system. But I got a yes. So now I have to check the second one and make sure it works in that as well. So now I'm going to, again, replace my Y with a 10 and replace my X with the 4 because that's the pair that we're checking on. So the left side is obviously 10. This would be 8 plus 2, so the right side is 10. Now, in this example, these all equaled 10. That doesn't have to happen. I just need the top to be true and the bottom to be true. So if I got 10 equals 10 on the top and 3 equals 3 on the bottom, that's totally fine. But in this case, the question is, hey, is 410 a solution to the system? And the answer is yes. And that's what you would need to say. But the reason is that it makes both, that's the key, it makes both equations true. So mathematically, plugging in those x, y coordinates, those coordinates make both equations true. All right, so let's give this one a whirl. I'm plugging in an x for 2 and a 2 for x and a 2 for y. Okay, so let's see, is that a solution to the system? I'm going to check. So in my first one, I'm going to go this direction so I have a little more space because this looks like it's going to require a little bit more math. So I'm going to check that equation, and I'm going to check the bottom equation, and I'm putting in a 2 for x and a 2 for y. Then I'm just going to show my steps. This is going to be 20 plus 2 times 14 will be 28. And I'm checking to see, does it equal 20? So these will add up to be 48, which does not equal 20. So I can already answer no. I don't even really have to show this one. Now this one turns into 8 plus 2 equals 10. So this side checks, but since the first one I did doesn't work, I already know that this can't be a solution to the system because it already didn't work in the first one. So it doesn't really matter if it works in the second or not. The definition is it has to work in both. So try this one yourself, decide if you believe this is yes or no, and then you can start the video again and see if you did this correctly. So I'm putting into each equation, I'm putting in a 2 for my x and a 6 for my y. Okay, so this one, I'm going to get a no again because even though it worked in this first one, so I was halfway there, it does not work when I plug it into the second one. So it cannot be a solution to the system because it has to work in both. So the point here in these first 4 examples is for you to get comfortable with the idea that a system of equations means you have more than one equation, more than one variable, and that in order to be a solution, both the x and the y values have to make both equations true. So that's how you test to see if a point is a solution. We'll actually spend most of chapter 7 learning how to find the solutions, not just saying, does this work? Does that work? Does this work? So we have to come up with some methods for how we're going to go ahead and find that. So the first way is through a method we call graphing. Every point on a line is a point that makes that particular equation true. So in this particular drawing, if I drew in this line, this is actually nothing more than all the points, all the x's and all the y's that would make this equation true. Likewise, if I look at this other line and I say, okay, all the points along this line are going to be x and y pairs that make this equation true. So if you're looking for the solution to that system, meaning both equations at once, because over here they have our system written, but it's nothing different than the 2 equations that have been graphed. So we had equation 1 graphed here as line 1, and then equation 2 is graphed here as line 2. So when you're looking for a solution, you're going to be looking for their common point, their point of intersection, where they cross, however you want to think about that. And so it's going to be an x and a y, and it's going to be the one they share, because that one works for line 1 and that one works for line 2 as well. So what I do is I look at my graph and I say, okay, what coordinates are located right here where they're crossing? So keep in mind, we put the x first and then the y. So starting at the origin, I would go 1, 2, 3 in the x direction. And then I would go up 2 in the y direction. Now, if you're asked to solve, or excuse me, if you're asked to show or prove or verify that that is indeed a solution or double check, you can go ahead and do what we did up above. You would go to equation 1, and where there's an x, you'd put in a 3. Where there's a y, you'd put in a 2. You would verify through just doing regular math that that one does indeed check out. Then you could go back and say, okay, I'm going to check because I'm taking a test, or you really just want to be sure. And I'm going to go to equation 2. I'll again put in my x value as a 3. And here where there used to be, a y, I'll go ahead and have minus 2 times 2 and see if that equals 5. This will be 9 minus this, which is 4. And that will indeed check out to be a 5. So you can always check. I always tell my students at the high school that this is a test where you can check your own paper. You know when you're turning it in whether it's actually the solution or not, because you can plug it in and see if it makes it work. So in this next one, we have equation number 1. Negative x plus y equals negative 7, and they've got it labeled down here. So this is going to be the line that goes with equation 1. And then the second one is x plus 4y equals negative 8. And thank goodness they're graphing these for us, because that would be a lot of work for us to do that as well. But this is going to be the line for the second equation. So I'm going to call it line 2. I am solving. The verb that goes with it when you're looking for a solution is to solve. So if I'm solving the linear system, that simply means I'm looking for the answer to the system that's made of lines. So they graphed both of them, and I am now going to look for that common point, that point that they share. So the shared or common point, and therefore the solution, appears to be, let's count from the origin, which is up here. I have to go to the right. 1, 2, 3, 4, down 1, 2, 3. So if I went 4 in a positive x direction and then down 1, 2, 3 in a negative y direction. I want to triple check that I'm right. So I go back up here and I take my first equation. It says negative, and then I plug in my x plus, now plug in my y, equals negative 7. These two do indeed become negative 7, so it checks in equation 1. Then I want to check in equation 2. So I'm going back and I'm taking a look at this second equation. Where there's an x, keep in mind this is my x and y, I'll put a 4. And where there's a y, I'll put my negative 3. So this product becomes negative 12. And you could certainly check these on your calculator, because you want to make sure that you do parentheses, exponents, multiplying, dividing, and then adding and subtracting. It's still important to do things in the proper order. That's why I multiplied the 4 and the negative 3 first. Now I'm going to go ahead and put these together. Excuse me, and that checks as well. So the answer is simply this part. Hey, here is my XY coordinate pair that works for both equations, meaning that's my solution. In the previous problem, 3, 2, that is my solution. It's my common point. It's the XY coordinate pair that works in both. And then up here, this whole front top part is going to be the part that allows you to check your own answers and see if the answers you got are indeed solutions. So coming out of this out of these notes, you want to be familiar with the terms system of equations, solution. You want to know how you test that by plugging in your x's and y's and seeing if it works. And you want to know that when you're looking at graphing, the solution will be the point that they have in common. All right, so maybe stop the video and try some of these, because here we do have to graph them. So I'm going to go ahead and think back to when we learned how to graph. I'm thinking about y equals mx plus b. I might use graphing by intercepts, whatever makes it easiest for me to graph. And you're going to see that sometimes the graphing method is not super easy or efficient. which is why we're going to learn some other methods later, because it's tricky. So we have to think back to graphing. I'm going to think about this as 5x plus 0. Keep in mind that this is my y-intercept. This will be my slope. So my first line starts at 0 on the y-axis and goes up 1, 2, 3, 4, 5 over 1. Now I'm going to go backwards, 1, 2, 3, 4, 5, back 1. And I'm going to do the very best that I can to get a decent line going through there. And that's line 1. Now I'm going to attack the second one. Ooh, that starts at 10. Excellent. That's way off my chart. So 6, 7, 8, 9, 10 goes down 1, 2, 3, 4, 5 over 1. Well, that's handy. And then it goes down 1, 2, 3, 4, 5 over 1. The reason I think that's so handy is thankfully while I was doing that line, I saw right here where they're going to cross, and that makes this point my solution. What are the coordinates of that point? Well, starting here at the origin, I go 1 to the right, so that's my x, and then up 1, 2, 3, 4, 5. So 1, 5 is going to be my solution to this first system. And like I've been saying all along, I can go in here and I can say, okay, if I put this in for x and this in for y in my top equation, y equals 5 times x. Yep, that works. How about the second? Does 5 equal negative 5 times 1 plus 10? If you do that on your calculator or think through in your brain, yes, that works as well. All right, so let's tackle this next one. This next one looks kind of tricky, I think. And so it's going to be a little challenging to graph. I'm actually going to go to the second one because that looks easier to graph. So I'm going to graph at 4 on the y-axis because that's what my y-intercept is. And then using my slope, I'll go down 2 over 1, down 2 over 1, and so on. So I'm going to draw that line in. If you have a straight edge or if you use Notability, that's going to be super helpful because if you have really messy graph, and that's what I'm afraid of here, is you're going to have a hard time figuring out where they cross. Okay, let's see. What about this one? What if I want to get it into slope-intercept form? Well, I'm going to need to add an x over. We did all this in the previous chapters, but we got to dig deep into our memories now to remember this. And this is why this one's going to be tricky. Because when I divide each part by 2, I'm going to get y equals 1/2 x plus 1.5 or 3/2, however you want to think about that. So when I go to graph this one, I'm going to shift colors here. I'm going to start at 3/2, which is 1.5. So I'm in the middle here. And then I'm going to be going up 1. So I have to go to the middle above that and then over 2. Up 1 over 2. So when I connect these, I'm trying to be as careful as I can and precise as I can because my next goal is to say, where do they cross? And it looks like they cross right here, which my solution will be the coordinates of that point. And it looks like I go over 1 for the x and then up 2. And then, like in all the problems, I can go back to these original problems, plug those values in, and see that those are real solutions. All right, let's try one more. Again, if you want to turn your video off, try it yourself. These are challenging, and so you want to really walk through them and practice before trying to do the homework or quiz. So this starts at -5 on the y and has a slope of 1. So up 1 over 1, up 1 over 1. I like to get a lot of dots so that my line can be more accurate because I'm not awesome at drawing those straight. Thanks, Notability, for helping out. And my last one, my grand finale, starts at 3 on the y. And then a slope of -3 means down 3 over 1. Down 3 over 1. So I'm going to draw that line in. Do my best to be accurate. If you're using paper, super good idea to get a ruler or a straight edge to help. And now I'm looking at my graph and saying, okay, this is where they cross. Where is that located? Starting at the origin, I go 2 to the right, so 2 for an x, and then down 1, 2, 3, -3 for the y. That will be my solution. And again, I can go up to my original problems and I can work through there, putting in 2 for my x's, -3 for my y's to confirm that those are indeed the solutions. So we're kind of at a place now where we have to draw on things we've already learned. Like this part is real tricky if you never learned the graphing of a line. And so now's the time that we're really putting the things we've learned throughout the year together. If you need to watch the video to remind yourself how this works, whatever parts of it you might need, feel free to go back and look at them because you want to make sure you understand before you move on to the next thing. All right, friends, see you soon. Have a good day.